Okay, so in this video I wanted to do another example from our homework of how to graph rational functions. This time we don't have oblique asymptotes, but we might have a couple or more than one vertical asymptotes. So let's get started. We have f of x equals 10x minus 20 over x squared minus x minus 20. So in order to get started here, remember the first thing we do when approaching a rational function like this that we wish to graph is to see if we can factor and find asymptotes, maybe even cancel and find wholes. So if I were to factor this right now, notice that we have a greatest common factor of 10 in the numerator. So that's x minus what? Well, if you pull out the 10, 10 times x is 10x, and 10 times what would give me negative 20? If you said negative 2, you'd be correct. For the denominator, we have a special trinomial here that does appear to factor. Can you pause and see if you factor it yourself correctly? Did you get x minus 5 and x plus 4? Good job if so. Now that you've factored it correctly, we should be able to notice that we do have vertical asymptotes in this case. Remember, vertical asymptotes are when we don't have cancellation, because that would be a whole, but instead we still have factors in the denominator, which could be problematic. They could be 0. So if I want to find my vertical asymptotes, noticing that nothing canceled, there's no wholes, but there are two vertical asymptotes. They are when this factor equals 0, x minus 3 equals 0 means x would have to equal 3 for that to happen. So that's problematic. And x plus 4 equals 0 would mean that x equals negative 4 is also problematic. So these would be my two vertical asymptotes, which I can put on my graph right now as places where the graph breaks apart. 1, 2, 3. I'm going to put my vertical asymptote there at x equals 3. And then at x equals negative 4, 1, 2, 3, 4. There's another vertical asymptote. So the graph breaks apart at those two locations. Now what about horizontal asymptotes? How did we find those? Horizontal or slant asymptotes are found by comparing the degrees of the numerator and denominator. They're mutually exclusive, meaning if you have a slant, you don't have a horizontal, and if you have a horizontal, you don't have a slant, and sometimes you have neither one. So look at the degree of the numerator. We usually call that n in the notes. The degree of the numerator is a 1, isn't it? And the degree of the denominator is a 2. So the numerator's degree n is less than the denominator's degree m. In this scenario, you can look back in your notes and video for this section. You would remember that in this scenario, the denominator is always growing faster. So as x values get larger, the entire function approaches 0. In other words, we have a horizontal asymptote in this situation, and it's when y equals 0. And if we have a horizontal, we don't have a slant. So we can graph y equals 0. It's the horizontal line, basically the line on the x-axis if you were to superimpose it. So this is the horizontal asymptote, y equals 0. Remember, we are allowed to touch horizontal or slant asymptotes. We just can't touch vertical asymptotes. So we have an idea now that the graph is either going to be up here or down here, maybe up here completely or down here completely, or maybe it'll be like a snake, like this or like that. And then in this region, here or here. So let's see what else we could find using intercepts. So to find our x-intercepts, for example, sometimes that's more complicated, especially if nothing factors in the numerator. To find x-intercepts, you let the entire y equal 0, but if y equals 0, that means the numerator equals 0. Because if a numerator equals 0 in a fraction, that makes the whole thing 0. So you could set the original numerator equal to 0, but I think it's even easier to notice that in the factored form, if you set this equal to 0, 10 can never be 0, but x minus 2 could be 0 if x equals 2. You could also have set 10x minus 20 equal to 0. You'd get 10x would equal 20. Divide by 10, x is 2. So this is the only time at the point 2, 0, so 2, 0, 1, 2, that would be here, where we're allowed to cross the x-axis. Notice that is on the horizontal asymptote, so that is going to get crossed. We're aware of that. All right, so we found the one and only time where we cross the x-axis. Cool. To find the y-intercept, remember a function can only have one y-intercept because it has to pass the vertical line test. We would let our x value equal 0, so we'd say the function's input is 0 for x. What is the output? Well, if I input 0 in the original, notice 10 times 0 is 0, minus 20. You just get negative 20 in the numerator. And in the denominator, if you input 0 for x, that goes away, and you just have negative 20. In other words, negative 20 divided by negative 20, which is just positive 1. So the only time where we're allowed to cross the y-axis is the y value of 1. That's what we mean by an intercept, right? So the y value of 1 is where we will be crossing the y-intercept. Well, now I have a better picture in mind of what's happening here. Notice I could now graph the function in this region. I know that I have to be in both, I have to cross both the x-intercept of 2 and the y-intercept of 1, but I can't turn back around because if I do that, I would end up crossing the x-axis again. So instead, I'll be approaching my vertical asymptote of x equals -4 from that direction. So it's kind of curving up. Sorry, it's rough to see that here. It's going to go through 2, curve up, go through 1 at the y-intercept, and continue. Okay, but what else do I need? I need some test points. So let's get ourselves some test points. What do I mean by test points? I mean pick some points which are in the regions where you're not sure about. For example, I'm not sure, are you? After 2 here, am I going back up or am I going to come back down? So I'm going to pick a value to the right of 2, but still less than my vertical asymptote. Oh, you know what? I realized I made a mistake. Did anyone else catch me? Okay, notice what I typed here. I typed in x minus 5 times x plus 4, but I accidentally misread my own handwriting, and I read that as a 3. So I apologize. You might have been shaking your head at me the entire time. That should be x equals 5. So let me scoot this on over just a little bit. Sorry if I confused anyone unnecessarily. So there's the 2, 3, 4, and 5. That's the location of that vertical asymptote instead of 3. I apologize for misreading my own handwriting. Sad day. So hopefully I didn't lose anybody there. Okay, so that was a 5, but I misread my own handwriting and made it a 3 by mistake. Okay, well, so now I have even more options. I need to figure out after the x-intercept 2, am I going to be coming down here or am I going to go up here? So I pick a value. How about 4? Let's test 4. If I were to plug in 4 right now into my function, let's get our test points here. Some test points. If I let x be 4, that would mean plug in 4 into your function. So let's see what happens. I would have here, for example, 10 times 4, which is 40, and 40 minus 20 is 20. If I put 4 in the denominator, you could put it in either place here. This might be easier. This is a 5, remember? 4 minus 5 is -1, and 4 plus 4 is 8. So I should be getting here 20 over -8. And I could reduce that. Both of them have a 4 as a factor. 4 goes into 25 times, and 4 goes into -8, -2 times. So -2.5, or -5/2, would be the output at this input. So at 4, I'm down somewhere at -2.5, -1, -2, -3. So somewhere in this region, I have that test point. So I can now continue my picture in that region, right? I now know that after the x-intercept 2, I'll be coming down so that I can cross this test point of -4, -2.5 and continue toward my vertical asymptote of x equals 5. Okay, I have 2 more regions to check out. Let's check out what could happen in this region, for example, to the left of the asymptote x equals -4. Again, I need to pick a nice x value which is left of -4, so something to the left of this vertical asymptote. How about -5? Let's see what happens. So input -5, you can use your calculator or do it by hand. If you input -5, you would have 10 times -5, which is -50. -50 minus 20 is -70. And if you put -5 into the nicer factor denominator, -5 minus another 5 is -10. And -5 plus 4 -5 plus 4 is -1. So I have -70 divided by +10. In other words, -7 when I simplify. So at the input of -5, my function gives me the output of -7. So at -5, that's 1 to the left here, at -5, I need to go down 7 units. And that's where my point is. 4, 5, 6, 7. So here's -7. This was -3. This was -2. So somewhere down here is another test point at -5, -7. Now I know what's happening in that region of the graph. I am below this horizontal asymptote and left of this vertical asymptote. In other words, I know that the picture should be looking something like approaching this asymptote and slowly approaching that asymptote. So the graph in this region, it might look a little bit curvier. Sorry for the ugly graph. Something like that's happening, but definitely going through my test point of -5, -7, and approaching my horizontal asymptote of y equals 0, and approaching my vertical asymptote of x equals -4. Finally, to figure out the region to the right of the asymptote x equals 5, I pick a test point that is to the right of x equals 5. How about x equals 6? Let's see what happens at x equals 6. So let me continue with my test points here. F of 6. If you input 6 to your function, 10 times 6 is 60, and 60 minus 20 is 40. Divide that by, again, the input of the denominator when you have 6 here. 6 minus 5, in the factored version is easier. 6 minus 5 is 1. And 6 plus 4 is 10. So I'm getting 40 divided by 10. Or in other words, simplifying, 40 divided by 10 is just 4, isn't it? So at the input of 6, I should be getting an output of 4. Let's check it out in the graph. At the input of 6, this was at 1, so 2, 3, and 4. There would be my test point there in that region, 6, 4. So that my graph, now we know, is above the horizontal asymptote in that location. So to the right of 5, we should be above our horizontal asymptote. So something like this is happening. We approach it, and we approach that one as well. So now we have our graph. We've sketched our graph that has several pieces here. The more vertical asymptotes, the more pieces you have. So what we had to do first was factor. Notice that nothing canceled, so every factor of the denominator did become a vertical asymptote. I apologize again for the handwriting error. That was a 5, not a 3, which created this asymptote of x equals 5 and this asymptote of x equals -4. Once you had your vertical asymptotes, you needed to find your horizontal or slant asymptote, and you did that by comparing the degrees of the numerator and denominator. Because the degree of the numerator was less than the degree of the denominator, that was the case where the denominator is growing faster, so the whole thing is getting closer and closer to 0. So we put our horizontal asymptote at y equals 0, remembering that we are allowed to cross horizontal and slant asymptotes, just not vertical. Then we found our x-intercepts by letting our y value, f of x, equals 0, which really just means your numerator equals 0. So if you use the factored version, 10 can't be 0, but x minus 2 could be when x equals 2. So we went to the graph, and at 2, we put our one and only place where we're allowed to touch the x-axis, which happened to be on the horizontal asymptote this time. To find my y-intercept, I had to let x equal 0 in the function. So if you input 0 here in the non-factored version, original version, we got -20 over -20, which was 1, which means when x is 0, y is 1. So 0, 1 was my one and only y-intercept. Finally, once I had those two values, that intercept and that intercept, I could graph that region, but I didn't know what happened to the right of it. I needed to know, was it down here or up here? So I picked a test point in between, like 4, plugged it in, and got -2.5, which meant the graph needed to come down there. Finally, I needed to know what happened in this region to the left of the vertical asymptote x equals -4. So I picked a value like -5 as my input, and I got -70 over 10, which is -7. That meant that the graph is down here. And finally, to figure out this region to the right of x equals 5, I picked a value to the right of 5, like 6, and I plugged it in and got 4, which meant I'm up here instead of down here, and I graphed accordingly. Now, we picked really nice numbers. Sometimes you'll get nasty fractions, but the key thing is, am I below or above? That's going to help you determine your sketch. Well, I hope that helped, and happy practicing, because math is not a spectator sport, and I'll see you next time.